Assalamualaikum and greetings. My name is Dayang Nurina binti Muslim, and my teammate is Mupa anak Jelingau. The purpose of this video, as you can see on my screen, is we are doing a presentation for our mini project which entitled Pick and Place Basic for Waste Metal. For our mini project, we will use Siemens step portal with a S71500 PLC SIM and Factory I/O to see a virtual industrial environment of our project. The function of our project will be used as a machine to separate metal waste from other solid waste at a waste disposal site, where it can solve or point out the problem when the recycling process of metals such as fuel has to be used and metal trash is often dumped into landfills, where it will be lead to a pollution such as air and water pollution.
System for our mini project. As you can see, I have 26 total of HTML here, where it refers to input, output, and counter for our system. So we have input, output, and counter, and the data type, bool and dword. Dword is for counter, and the address, we have Q, which it refers for output, I for input, and memory. This is the example of tag that has been defined for metal. Meanwhile, for button, I will set it under event, where when we press the button, we will see the function. Then for counter, the Factory I/O will be functioning as well.
First of all, thank you to my teammate of the mini project, Dayang Nurina binti Muslim, because his explanation before this. Okay, my name is Mupa anak Jelingau. So I am here. I will present more detail about our mini project. Also, I will present the simulation of this our mini project. Okay, first of all, I will explain our mini project for the ladder diagram or the function block. Okay, if we look at my screen, okay, if you look at my screen, this is for our ladder diagram. Okay, for our mini project have the seed network, okay, network of the ladder diagram. Okay, if you look at the network, first is for the Factory I/O function. Okay, that function, this template when we want to the simulate of the mini project. Okay, for the network number 2, the number 2 is control panel light and the switch. Okay, if you look at this ladder diagram, okay, the diagram provide for the start button, stop HMI, okay, start HMI, attempt at entry using for the normally close, and then emergency stop, entry conveyor, start light, entry conveyor, and then at the same time our mini project is provide to condition for the automatic, also provide to the manually. Okay, and then we look at the last this, have the reset button, reset timer, reset counter, reset light. Okay, and then reset for the HMI. Okay, next is network 3. Network 3 is for the move Z actuator downward and upward. Okay, for when the item at the entry, okay, if you look at the address I0.0, okay, then go to the stop button, emergency stop button. Then grab will be on the normally closed. Okay, and then move Z. Next is the go to the moving X. Also timer using for this network 3 to 100 millisecond. Okay. Next, go to the network number 4. This network number 4 is for the pneumatically grab the atom. Okay. In this network number 4, when the atom was detected, okay, in this mini project we was using for the inductive and diffuse sensor. For the first part, at the entry conveyor, provide of the metal sensor. Metal sensor will be detect for the inductive sensor will be detect only for the metal item. When it detect, and then the pneumatic grab will be grab the atom and then send to the neck of the conveyor, and then at the same time diffuse sensor will be as the counter, detect and count of the metal atom. Okay, next is network number 5. Network number 5, this is move X actuator to right and back to the left. Okay. Okay. In this network number 5, we include the grab timer 2 second, move X, and then go to the timer 1500 millisecond. And then the last one is network number 6. Network number 6 is for the counter digital display. Okay, for this part, okay, the counter is using for this mini project is a diffuse sensor. If the diffuse sensor detect the atom, the atom, then will be count and display at the HMI panel. Also the HMI at the factory I/O. This atom is conditioned at exit. Okay. So if you want to reset of the counter, we can press the button reset. Also provide in HMI. Okay, that's only for our ladder diagram of function block. Okay, next I will to present about the HMI tag. Okay, for the HMI tag, we have provide alarm 2, counter, atom at entry HMI, atom at exit HMI, reset HMI, start HMI, stop HMI. Okay, next I will go through to the simulation using for the factory I/O. Okay, factory I/O. Before this, I will to present the driver of the factory I/O. Okay, this is sensor and actuator we are using of this factory I/O to run the simulation. Okay, we can see at our my screen. Okay, the inductive sensor, diffuse sensor, moving X, moving Z, atom detect, start, reset, stop, emergency stop, auto, factory running, entry conveyor, exit conveyor, move X, move Z, grab atom, start light, reset light, stop light, and lastly is counter QD30. Okay, so I'll go through the before this. Also, if we look at my factory and at my screen, okay, we are using the pneumatic grab this for grab the atom, inductive sensor for detect the metal atom, diffuse sensor is for the count and detect and count the atom. Okay, and then at the panel of factory I/O, provide the emergency stop, start button, stop button, and then reset button, and then display the counter. also provide a manual and auto button. Okay, so here I will go simulation. Okay, it is in condition of normally close, the in stop. Okay, stop for the stop button will be turn on stop button light. Okay, now we want to using for the auto mode. Okay, see when I press the start button, so if the so in this condition is inductive sensor detect the metal, so will be grabbed, pneumatic automatically will be grabbed and then sent to the diffuse sensor. Diffuse sensor detect and count and then display at the counter display. Okay, this is simulation. Okay. If the any atom different from the metal atom, so we go through the emitter remover. Okay, the pneumatic grab cannot grab the atom. For the metal, we will go to the exit conveyor. This exit conveyor. Okay. For the HMI WinCC, okay, WinCC or HMI, simulation HMI, if you look for this system, so provide the start button, stop button at the HMI. Okay, so provide the trend. Okay, the trend is for the display the data or the graph for the counter. Okay, automatically the value of the atom detect, the graph will be increased if you look at this trend graph. Okay, the value is delay because the trend is slow, but at the HMI panel and okay, we'll push stop button. Wait, okay, the stop when okay, when I press the stop button is for the conveyor stop, but the pneumatic grab will be as still function. Okay, at here we can look for the simulation, the atom. Sorry. Okay, wait. Okay, when I press at here stop, the system for this waste metal pick and place will be turn stop when I press the button stop at the HMI. Okay, so start again. So the machine will be continue function. Okay, when I will reset the counter, okay, stop will be reset the value of the metal atom detect. Okay, the last one is I will present okay, I will present about our HMI alarm. Okay, in the HMI alarm condition, if discrete and analog. For discrete is NG number 2 for the emergency stop press. Okay, when the emergency automatically press, so the alarm text will be displayed for the emergency button was pressed. This is alarm class for the error, means the project in is error, so need to take attention. So and then for the analog alarm. Okay. For the counter warning, okay, the counter warning is limit for the 5. Okay, when the metal atom detect more than 5, the analog alarm will be show the text warning count is detect maximum value. So we can look at for our in the project. Okay. Alright, that's all for our mini project presentation. Okay. For the conclusion of our mini project is actually this mini project is I have achieved of the objective of this mini project that I can design the system for the waste metal for pick and place waste metal, and then at the same time I understand and know how to design the system using the ladder diagram on all the function block designed at the HMI tech, also at the factory IO actually. Okay, so we hopefully this project can as the guided for the news for the next generation of this system. Okay, that's all. Thank you.